So Unit 4, Lesson 10. So this is the second half of our unit. I do have a new assignment sheet for you today that goes to absolute value. So this is kind of probably our biggest unit. I don't know if it's our hardest, but it's probably our biggest. So just a quick review of absolute value. Oh, what does absolute value mean? Yeah, what's it mean? Absolute value is the distance from zero. Okay, and that's why, what's the key word I just said? Distance, so it can never be negative. So but people just say, well, absolute values are things that can't be negative. Not really. Okay, absolute value is your distance from zero. So if I have negative 12, that's 12 spaces from zero. Okay, if I have 14, that's still 14 spaces from zero. So absolute value, some people think it's just switching the sign. Some people think it's opposite. Some people think just never negative. I would say distance from zero. Yeah. The only way you have a negative includes if the negative's outside the absolute value. You'll never, I'm not really sure what you're speaking to. Okay, so as I was talking about here, so the absolute value for a real number can be defined as the principal square root. What they mean by that is if you square the number and then square root it, that's the absolute value. I feel like that's kind of tedious, but why does that work? Because whenever you square a number, you always get a what? A positive. And when you square root that positive, you get that number. So 6 squared is 36, square root of 36 is 6. Negative 6 squared is 36, square root of 36 is 6. I prefer just distance from zero. Okay? All right. Let's see, this thing's being really, really touchy. All right. So let's do these here real quick. All right, so this is what I was talking about. So if we have 6 and negative 6, right here's negative 6, right here's 6, here's 0. The one from the negative is still 6 units. The one from the positive is still 6 units from 0. That's what we're talking about. Okay, so here's some quick absolute values. So what's the absolute value of 3? 3. Absolute value of negative 3. Okay, now this is where I was talking about. The negative is where? It's outside, so it's going to be 8, but that negative was not affected. So your answer is still negative 8. Yep. Let them in. Okay, now this one, it's a negative 8, which makes it a positive 8 with a negative that's not affected. So it's still negative 8. Hold on, just a second. Hold on. Okay, Sarah, go ahead. I just want everybody to hear you. It's the answer is negative, I guess the best way to say it. It's still 8 units from 0, but then multiplied by a negative 1. So we're still, absolute value is still like a separate thing, right? So every answer we're doing right now is not like a distance. Okay? Everything that we're doing is not distance from 0 except for the absolute value. So this right here is the distance from 0. What is that? That's 8. Then we're timesing 8 by negative 1. So it's like we're doing math operations. Okay, we're not just doing distance from 0. So yes, this does not mean negative 8 from 0 because that's impossible. Okay, all right, so then here I have negative 7, absolute value, that's 7, plus root 7, so I have 14. F, 1 minus 5 is negative 4, absolute value of negative 4, positive 4. Okay, now this one's got a lot going on here, so I'll let you kind of think about it and see if you get the right answer. But I can always tell you this, if there's a negative outside the absolute value, what type of answer are you going to have? A negative, for sure. It won't change. It can't change. Okay, so what's the square root of 81? So I have a negative 9. Absolute value negative 9 is positive 9, but then that says negative again. So negative 9. Okay.
You only include the negatives on that side, so pretty much all.
Whenever there's a negative on the outside, then the answer is going to be negative. no matter what. Okay, all right, next page. Okay, so now we're going to investigate in terms of the graph. Does anybody know what an absolute value graph looks like? No? No, you're still thinking inequalities. We'll get to inequalities next unit, Eli. You're going to be really good at inequalities. Yeah, that's what I think about this one. Okay, well, what does an x squared, because I think that's what we're going to talk about, what does an x squared and an absolute value have in common? No, not everything. Well, when we did our x squared and our quadratics, they were curved because of what? What was the whole purpose of them being curved? So they're not possibles because we are never getting what? Negatives, right? X squared, remember our parabolas, guys, if you forgot, that's last unit. Our parabolas do this because negative 3 squared and 3 squared are both going to be 9. Remember, we bend because we have to be all positive for x squared. So absolute values have that same principle. Because if I'm doing, that's 3. What's the absolute value of 3? It's 3, right? Absolute value of negative 3. 3. So it forms, and you're going to see, it forms a V. Okay? Absolute values form a V. That's what we're going to talk about right now. So it says consider functions of x and negative x. So how would you graph x? Are you guys familiar? Let's see if you guys remember here. Do you guys remember slope and all that stuff? Kind of like y equals mx plus b. Okay, well, like this one right here is just your basic linear line. Y equals x. So that means 1 equals 1, 1, 2, 2, 3, 3, 4, 4. Those are your points. And so that's going to be like this. That's y equals x. Just a very normal straight line. Okay, and then the y equals negative x is just negative 1 equals 1, etc. So it's going to look like this. The way I explain it with slope, but I'll talk to you about slope a little bit because you guys should know that, is that this has a slope of 1 and a y-intercept of 0 because there's nothing out here. That means it intersects at 0 and it goes up 1 over 1. That's your slope. Okay. For your negative x1, again, there's nothing out here, so it starts at 0 and it's down 1 over 1. Okay, so that's the relationship of those two lines there. They kind of make an x. Okay, and then it says, consider the function absolute value of x. Complete the table and plot the points. So we know that absolute value, if I'm doing absolute value of x, absolute value of negative 5 is 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, and 5. Okay, I just did the quick absolute values of those numbers. So now we're going to plot those points, and you're going to hopefully see something. Okay, so I have negative 5, 5, negative 4, 4, negative 3, 3, okay, so what do you see between the two graphs that we did? They're quite similar. What's the difference? The right one has nothing where? The negative, right? So it is the same, just this part's cut out because we can't have negative absolute value. So the reason we're showing you this is absolute value is a combination of its graph and its opposite graph. So our x graph and our negative x graph is the combination of our absolute value graph. Okay, and that's just a concept we're going to get to use because we're going to use this to solve. So if I did, we'll do one here in a second. I won't get too far ahead. But I want you to understand from this investigation is the absolute value is a combination of the opposite and itself. Okay, so let's fill out the questions here below. Absolute value calculators are the ABS. If you hit math, it's number 1, where it says ABS. see it, Davin? Did you see it? Yeah. Just want to make sure I was right. I think it's math. Okay, so 3. All right, explain the similarities, the difference between the graphs of the two grids above. We already did that. The similarities is the same. Why is it being so slow? The similarities were, again, the parts positive y were the same. Okay, so positive or when y is greater than or equal to 0, they were the same. Okay, when y was less than 0, not equal to, sorry, when it was less than 0, the y equals x, y equals negative x had points. The y equals absolute value x did not. So that was the difference. Okay, the graph of y, absolute value x, contains two straight lines connected. What are they? We know they're y equals x and y equals negative x. Okay, so now, remember, this function of x, f of x is just like y, okay? All this is just like a y, just like here. And this is how these piecewise things work. And these are important because we are going to use them. They are stuff you have to know how to do. This is talking about, because when you understand the v is a combination of two lines. Because it's a v, it completely redirects, okay? Completely redirects. It's not rounded. It comes down and switches direction, okay? So what is the equation of this line for our basic absolute value? Is that the negative x one or the positive x? Is it going down or is it going up? Yeah, it's a negative x. This is my negative x line. Okay, and this is my x line. Now what this piecewise is doing, it's breaking your v into two pieces because you have two. Okay, when x is positive, so this side, what is my graph? Is it x or negative x? This side. X, right? So I put an x here. So this says y equals x when x is positive. That's how you read it. Does that make sense? I want to make sure we get this, so if you have questions, say something. So how this piecewise works is y equals x when x is positive. So when x is positive, we have a positive x line. So then conversely, we have a what when x is less than 0? Negative x. That's how you fill out the piecewise there. Very good. All right, well, we have a lot of time still. Okay, let's go to the second investigation here. Next page. All right, so to find the absolute value, f of x equals absolute value of x. Okay, this is just defining it using the square again, which again, I don't think you need to do, but it's just saying that absolute value is the same thing as x squared square rooted. So again, that's another way of getting rid of the negative. Let's just do this. I like to think about it as opposite. All right, so let's do these two. So this is where we're starting to talk about non-basics. So x minus 3 is an actual equation. Okay? So consider the functions x minus 3 and then the opposite. Remember we had an x and a negative x? Now we're doing x minus 3 and the opposite. So when it says opposite, do we understand that the opposite of this is negative x plus 3? Because the negative and the negative. So this right here is negative x plus 3. That's what that equation is. Okay. So just real quick, what's negative 4 minus 3? We're going to fill out this table. Negative 4 minus 3. Okay, so there's my points for y equals x minus 3. So that's going to be 0, negative 3, starts here, and then it's going to be up 1, it's going to be like this. Okay, and down 1. So that is x minus 3. You can check all my points, they all line up. Negative 2 is negative 5. 1, 2, 3, 4, 5. Okay, so this is my positive 1. Okay, all right, let's do the negative 1 now. So if I plug stuff into the negative 1, what's negative 4 minus 3 is negative 7. Opposite of negative 7 is 7. Negative 3 minus 3 is negative 6. Opposite of negative 6 is 6. So we kind of the same pattern here. Okay, so plot this one. I have 0, 3, 0, 3 up, 0, 3 here, and it's going down. So this is my negative graph. Okay. Thanks. Okay, so now, Dumbo, stay with me. Okay, so absolute value of x minus 3. So now what I'm doing now is, I'm just going to fill out just using x minus 3. So negative 5 minus 3 is negative 8. Absolute value of negative 8 is 8. Negative 4 minus 3, again, it's going to be 7, 6, 5, 4, 3. This is where it gets interesting. 2, 1, 0, 1. It's not going to be negative. Because 4 minus 3 is 1, it bounces back up to positive 1. That's the v aspect. So let's go and plot these points. I know that 3 is going to be 0. That's what it looks like. So let's talk about a couple of things. How is this different from the last one? From the original, from just the absolute value of x? Well, it still has, yeah, that's the same. There's nothing on the bottom. Oh, I see what you're saying. Not from these two, from our last example, what changed? It moved over 3, right? Remember, what is it? It's x minus 3, right? Remember with parabolas on standard form? We moved what? Opposite? This is the same exact thing. Right 3. This movement is a horizontal movement of our v. Okay, it's horizontal movement, so it moved it right 3. Opposite. Okay, and then like James said, that's correct. Again, this one has the negative area, this does not. Okay, but the point is, here's my negative line and here's my positive line. They're connected. Boom, connects, and bounces. Okay? Questions on that? We got one more page. That's it. No questions? You got a question, Lauren? No? All right, so what do I got to talk about at the bottom here? Okay, so let's do our piecewise at the bottom. Okay, so this time they gave me my functions. So when was that v x minus 3? When was it the positive? X greater than or equal to what? No, 3. Because right here was where the point was, and from here on, it was the positive line. So from every number bigger than x is 3, it was your positive line. So then conversely, it was the opposite for x what? Less than 3. So what that's saying is, everywhere left of 3, it was your negative line? Anything on that? Please speak up if there's any problems with that. Okay. All right, last page. Okay, explain how the equation of the second piece can be determined from the equation of the first piece. All right. Yeah, this would be the opposite. Equation of the second piece opposite, or you can think of negative of the first piece. Okay, so the second piece can be determined by being the opposite of the first piece, or the negative. Explain algebraically without using a graph how the domain of each piece can be determined. So the 0, so what made that 0? X minus 3, what makes x minus 3 0? The plus 3, right? Well, that's where our v changed direction. Okay, so the 0, which we know how to do yet already, of the absolute function, is, I'm going to call it the change of direction. Or the two pieces that meet. So the 0, the absolute value, is where your v connects. That's where the tip of your v is. That's where your v is going to be. And from that place, and they call that P, just like we had P in standard form, so that point is P. Okay? So we know that X will be greater than or equal to P, and X will be less than P. That's where you're going to have your domain. It's going to be changing different graphs. Your change of direction. This point right here. All right, now we're going to do a little bit of practice with piecewise, and then we'll be done. Two problems, that's it. All right. Okay. All right, let's finish up. Okay, so express 3x plus 2 as a piecewise. Okay, express it as a piecewise. So we know that 3x plus 2 and negative 3x minus 2 are my positive and negative lines. Okay, where is their change of direction at, though? It's not at 0. No. Negative 2/3. What makes 3x plus 2 0? Negative 2/3. Okay, so negative 2/3 is your breaking point. So how you're going to write this is, I like to use y equal. The book's always going to have f of x, which is function notation. So it's going to be 3x plus 2 when x is greater than or equal to negative 2/3. Okay, it's going to be the negative line when x is less than negative 2/3. So what that means is this graph, here's 1, this graph hits right here, and then it goes like this. So here's my positive line, there's my negative line. Okay, so obviously a little bit different because they have a different slope, but we can talk about that when we get to the actual graphing part. Questions with that? Last one. Okay, so this one, I have y equals 4 minus x, and then a negative 4 plus x. Those are my two opposites of each other. So now on this one, Quinn, what makes that one 0? What makes 4 minus x 0? What's x have to be? Negative, negative, it's a negative 4. Positive 4, just as simply a positive 4. So positive 4 is my spot where they're going to intersect. So they're going to be right here, something like that. Okay, so this one, it's going to be the positive example for when x is less than or equal to 4. I'll explain that in a second. It is flipped. Okay. All right, this is how it's going to. This is why it's less than or equal to negative 4. So I actually drew that upside down. Sorry about that. What did a negative x do for parabolas? It flipped it, right? Same thing with absolute values. Absolute values are so similar to parabolas, it's going to make our lives a lot easier. So this actually is a flip down like that. But that's not important. The important part is, how do we get this flipped? I'll show you. So we always want to go 4 minus x greater than or equal to 0. We're just solving like inequality. Okay? Minus the 4. Negative x is greater than or equal to negative 4. And then what do I do now? Flip it because I'm dividing by the negative. So it's going to be x less than or equal to 4. That's where this comes from. Now, again, if you were completely lost on all this, that's how we do all of these. Okay? That's how we figure out, we take this and we solve for 0. And then this one's going the other way. Okay? So you won't use this to solve, just your original. And then go the other direction for the other piece. Okay? All right.